Hare Krishna. Now we are going to see naive string matching algorithm. It is a simple matching algorithm. It is very straightforward method used to find all occurrences of a pattern within a text string. It works by systematically comparing the pattern with substrings of the text one position at a time. Here the text string is considered of length n, whereas pattern of length m. We will consider this example to find the match. The given text is I am vegetarian and like to eat all vegetables, whereas the pattern which is to be searched in the text is veg. Here I have numbered the characters from the text string from 1 to 46. So that's how we get the length of text string, that is 46. Similarly, these characters from the pattern are numbered from 1 to 3. So that's how we get the m, that is the length of pattern 3. This naive string matching algorithm starts comparing character from pattern at the beginning of the text. It compares m characters from the text. If match is found, then it is hit. Otherwise, it slides window by one character from text and again starts comparison newly. Let us see how it performs character by character comparison. We have pattern of 3 length. The text window is always of pattern length. So the text window is of 3 length here. Comparison starts from the first character of the text window. This I, that is the first character from this text window, is going to be compared with the first character from the pattern. Now I and V, these two characters don't match. So that's how two more characters from this text window are not going to be compared. Instead, this text window will be slided by single character. Now it is starting with this space. This space is going to be compared with this V. Again it finds unmatch. So it will not go on comparing these remaining two characters AM with this EG. Instead, this window is going to be slided by single character, and now it is pointing to these three characters A, M and space. From this, the first character is the A, which is going to be compared with V. It finds unmatch, and that's how the sliding window is going to be moved by one position. It is pointing to three characters M, space and V. Starting character is the M, which is going to be compared with V. It again finds unmatch. So this window will be slided by single character, and with which it is pointing to the space V and E characters. Space is going to be compared with this V. Again it finds unmatch. So that's how sliding window is shifted by single position. Now it is pointing to the V, E and G characters. From this text window, V is going to be compared with this V. Match is found. So that's how the next character is going to be compared from the pattern. E both gets matched. The third character G also gets matched. So we may say that pattern is found at this position, which is pointed by V. Which is pointing to this V. 1, 2, 3, 4, 5, 6. So we may say the pattern is found at 6 location. So similarly, it compares the M characters from the text window. If match is found, then it is hit. Otherwise, it slides the window by one character from the text and again starts comparing the characters from the pattern. This continues till it reaches to the n minus m plus 1 position. See, here it don't compare till it reaches to the end of the string, because there is no point to compare all the characters from the string. Since the pattern is of 3 length, and by considering the case where the pattern is present at the end of this text, it would start at position 44. Since we are having the text of 46 length, the last three characters are starting from the 44th position. So if we consider that this pattern is present at the end of the text, then it would start at the position 44. If it don't match, then it is the part of common sense that the remaining characters are less than the pattern length, and hence it will not lead to the match. We will try to understand the code in Python for naive string matching algorithm. This naive string match function accepts two parameters: pattern, which is veg in our case, and text is I am vegetarian and like to eat all kinds of vegetables. The len, which is a predefined function from the Python, calculates the length of pattern as well as of text, and those get stored with m and n variables respectively. We use for loop as it is the iterative step to search for pattern in text window. As it is earlier told, it's totally useless to search for the pattern up to the last position of character from the string. By considering the case the pattern is located at the end of string, it will start at location n minus m plus 1. Here we have 46 characters in the text and 3 from the pattern. So if it is present at the end, then the last text window would start at the 44 position. 44, 45, 46. And the respective characters must be V, E, G. If it don't match with this 44th character, then there is no any point to look for the pattern with the remaining characters, because it is less than the remaining characters are of length less than the length of pattern. Hence we use the for loop of the range 0 to last text window's starting position, which is n minus m plus 1. Theoretically, we have numbered the text characters from 1, whereas computer programmatically stores the text from the 0th position. So with theoretical representation, we do have range from 1 to n minus m plus 1, whereas programmatically we do have range from 0 to n minus m. Here n minus m is 46 minus 3 plus 1, that gives us the 44 location. So by considering the case where the pattern is present at the end of the string, it should start at the 44 position. And the same is specified here. The for loop is written for I in the range of n minus m plus 1. So when we say I in the range of n minus m plus 1, it takes values from 0 to n minus m. Then we have initialized j equals to 0, which is going to point the characters from the pattern. So the pattern is V, E, G. So V is numbered 0, 1, 2. We have seen in example it searches for pattern in the text string. So pattern length equaling characters are going to be compared, and it is mentioned with the condition j less than m. So how many characters it is going to be it is going to compare with the text window. Text window is of m length, and those many characters at the most are going to be compared. So that's what this condition specifies. Then second condition is that text of I plus j equals to pattern of j. Hence we use the for loop of the range 0 to n minus m plus 1. N minus m plus 1 is representing the starting position of the last text window. Theoretically, we have numbered the characters from the 1. So the whereas computer programmatically stores the string from 0th position. So theoretically, we do have range 1 to n minus m plus 1. By considering the case where the pattern is present at the end of the string, it should start at the location 44. How to get this position? This n is 46, m is 3 plus 1. 46 minus 3 plus 1 is 44. So theoretically we do have range 1 to n minus m plus 1, whereas programmatically we do have range 0 to n minus m. So when we say I in range of n minus m plus 1, it takes values from 0 to n minus 1. Then we have initialized this j with 0 value, which is going to point to the characters from the pattern. Pattern is wedge and it is numbered from 0, 1 to programmatically. We have seen in example it searches for pattern in text string. So pattern length equaling characters are going to be compared, and it is mentioned with the condition j less than m. Since pattern is of 3 size, only 3 characters from the text window are going to be compared. So text window is of same length as that of the pattern length. The second condition is representing the character by character comparison. It checks for text I plus j equals to pattern of j. Then only the next character from the pattern is going to be compared with the next character from the text window. Otherwise it will skip everything if it don't match. If the characters from the text window don't match with the character from the pattern, it simply breaks this and increments the I value. Now we will see how it performs the comparison. This is the first text window which starts with the 0th position. Similarly, this is the pattern which also starts with the 0th position. So initially I is equal to 0 as well as j is equal to 0. The first character from the text window is going to be compared with the first character from the pattern. It finds unmatch. So that's how I is going to be incremented. See here, this part is not going to be executed since it finds the condition is evaluated to false. So this part is skipped and the I value is incremented to 1. Now it is covering these 3 characters which are starting with this space. Now space is going to be compared with V as it finds unmatch. Again I value will be incremented to 2. Now it is pointing to these 3 characters. This text window is with these 3 characters which are located at position 2, 3, 4. Then this A will be compared with V. Again it finds unmatch. So this text window is slided by single character. Now it is pointing to these 3 characters, M, space and V. M is going to be compared with V. It finds unmatch. So I is incremented to 4. And now it's pointing to space, V and E. So 4, 5, 6. These locations are going to be pointed by the text window. Now this space is going to be compared with V. Again it finds unmatch. So I is incremented to 5. Now it's pointing to these locations which are starting with 5 and the text window is of pattern length. So it is ending with this 7th position character. Now V is going to be compared with V. It is match. So see here, it's written here, text of I plus j is equal to pattern of j. Here I is 5, okay, and j is equal to 0. This 5th position character from the text is going to be compared with V, which is located at j is equal to 0. It is matched. So j is going to be incremented by 1 position. Now j is 1 and it is going to be compared with I. For this text window I was 5. So 5 plus j value which is 1. So 6th character from the text string is going to be compared with the j is equal to 1 character. See here. The same condition is written here. I plus j. I is equal to 5. 5 plus 1 is 6. Text of 6 means 6th character from the text is going to be compared with the pattern of 1. Okay. And it finds match as this E and E both are matched. Then this j is going to be incremented. What do we do? on finding the match, we increment the j value. So it is now incremented to 2. We add it to the I value. I is pointing to the 5. So 5 plus 2 is 7. Now this 7 character, that is the G character, is going to be compared with the G character which is pointed by J. Okay. Here also we find the match. Then as I said, whenever it finds the match, it's incrementing the J value. So J is now reached to the 3. We know the pattern length is of 3 length. Pattern is of length 3. Okay. Now on incrementing J, it has reached to the 3 size, means all the characters from the pattern has been compared and all match with the text window characters. So we may say the string is present at the index I. Okay. Because we have not incremented I, instead we have incremented J, and that respective text window or that respective text characters from the text string are compared. Okay. So we may say that pattern is found at I position, that is the 5th position. Similarly, it will continue up to the position n minus m plus 1. So I guess with this video, this naive string matching algorithm must be clear to you. Thank you.